In this video, I'm going to show you how to solve this integral using the most basic integration technique, u substitution. Yep, this integral right here is u substitution. It's nothing more than that. You might look at it and think maybe it's trig sub because of the square root of x plus 1 and nothing really more in there. You might think you can do it with IVP, but the best method you can use for this problem is u sub. So remember, 1 plus square root of x is the most inside and ugly part of this integral, right? So let's go ahead and call that our u. Right? Now, one more step we can take is to find our du. And then don't forget the dx there as well, right? So now, the next step what we can do, and hear me out on this, but I think the best thing that we can do right here is to do 2 square root of x d equal dx, right? Now this might seem incorrect, right? Usually when you bring things and multiply them, or du divided by them, you're trying to get everything in your integral in terms of u. And if we can write our integral out after doing this trick, 2 square root of x square root of u du, we're stuck, right? There's nothing really we can do here. There's no additional substitution. But remember, guys, there's a trick. U equals 1 plus square root of x, right? So there's something we can do there. What if we write u minus 1 equals square root of x? Oh, and then we can replace this into our integral, right? So let's write another step. We can first take the 2 out because it's a constant, right? And then remember, we said that u minus 1 equals square root of x. And now look at that. Our entire integral is in terms of u. Nothing more there. That's all we needed to do. We just needed to simply rewrite our u equals 1 plus square root of x. We need to make that square root of x equal u minus 1. And now we can FOIL this in, right? We can multiply it by this and by this. Let's keep the 2 on the outside. And then we can write square root of u times u, right? Minus just square root of u, right? Because you're just multiplying it by the 1. And then parentheses, all that multiplied by du. Now square root of u times u is just algebra, right? U, remember, by itself just equal to u to the power 1, and then square root of u is equal to u to the power 1 half, right? Now you can write 1 as 2 over 2, and then we can keep this as 1 half. Since we're multiplying these together, we're going to simply add 2 over 2 plus 1 over 2. We are going to obtain 3 over 2. Minus u, and we can write it as 1 half. Cool, right? And now we can integrate this. We can do inverse power rule, and we can say that 2, keep that on the outside first, right? U to the power, remember we're adding 1 in the power, so we're going to get 5 halves times 2 over 5 minus 2 thirds u to the power 3 halves. Do not forget the plus c, right? So next step what we can do is we can multiply our 2 in. We're going to get 4 fifths u to the power 5 halves minus 4 thirds u to the power 3 halves plus c. Now finally we can replace back in, so we can write that 4 fifths 1 plus square root of x to the power of 5 halves minus 4 thirds 1 plus square root of x to the power 3 halves plus c, and that will be our final answer. This whole problem looks really menacing. Looks like it's going to take forever, right? But really it's just a simple u sub. Like all of these problems, they look kind of crazy, but when you really work through them, play around with them, you get an answer that's actually not going to take you 2-3 hours of your life, and really maybe 2-3 minutes. That is how you solve this problem.